Hello and welcome to this video on carboxyl derivatives. My name is Ochem, and in this video we'll be predicting the products of a transesterification reaction, or swapping out one ester for another. Let's break down the term transesterification. Trans means across, and ester is a functional group defined by an acyl group bound to an alkoxy, OR. The reactions described by transesterification is where the reactant is an ester and you're creating a new ester by the use of either an alcohol or an alkoxide anion. Just like all of the nucleophilic acyl reactions described in this series, the reaction mechanism is the same, a nucleophilic acyl substitution reaction. You start with an electrophilic carbonyl carbon, electron-rich nucleophilic oxygen, loss of a leaving group, and the formation of a new product that contains an acyl group. Since the nucleophile is an oxygen that is attached to more alkyl groups, then the product will be an ester, which is the same functional group that we start with. There are two different methods for transesterification reactions, which is dependent on the kind of nucleophile you have. If the nucleophile is an alcohol, then the reaction must proceed via an acid catalyst, since alcohols are not very good nucleophiles. If the nucleophile is an alkoxide, the reaction is said to proceed via a base-mediated nucleophile, since the alkoxide is a strong base. For more information on how to distinguish between these two types of reactions, please refer to the video series on nucleophilic acyl substitution. Let's see an example of both of these types of reactions. We're asked to predict the products of the following reactions. In A, we start with naphthalene 2-il acetate, which is reacted with propanol and acid. The reaction proceeds in a stepwise manner. First, the acid will protonate the carbonyl oxygen to create a positive charge, drawing even more electron density away from the electrophilic carbonyl carbon. Since the alcohol is a poor nucleophile, the reaction needs to foster a stronger electrophile to compensate. Next, the nucleophilic oxygen will attack the carbonyl carbon, causing a shift in electrons to produce this intermediate. Loss of the leaving group and deprotonation of the alcohol will promote the acid to be regenerated, and our final product is naphthalene 2-il propanoate and methanol. We've switched from an ester with one carbon attached to the oxygen to an ester with 3 carbons attached to the oxygen. In B, we have 4-amino phenyl acetate reacting with ethanol and sodium ethoxide, where ET stands for a 2-carbon chain. One thing I always struggled with in organic chemistry was trying to decide what the solvent was and what the nucleophile was. We just saw an example in Part A how an alcohol acted as a nucleophile, but remember that it also required acid, so ethanol can't be the nucleophile. In this case, remember that sodium salts dissociate in solution so that you form sodium ions and ethoxide anions, and the formal negative charge on the oxygen would make a fantastic nucleophile. Since ethoxide is a strong base, this is an example of a base-mediated reaction. The negative charge on the oxygen will attack the electrophilic carbonyl carbon, and shifting the electrons will produce this intermediate. Loss of the leaving group will create our product, ethyl acetate, and the leaving group, 4-amino phenol. Remember to use the names to help you remember what's going on. A transesterification reaction is just changing the specific type of ester using the familiar nucleophilic acyl substitution reaction. Pay attention to the type of nucleophile you have, and you won't have any problem predicting the product of these kinds of reactions.